Hi, 230. It's Mrs. Lee, and Walter, he moved a little bit away from us. So this is the lesson for Friday, not February, April 17th. So I want you to stop the video now if you haven't done the work. So what I want you to do is I want you to do the work first, try it on your own, and then watch the video to explain what was going on and how you could have solved it, okay? So I want you to do the work first and then watch this video. All right, so in the work, in this task, it says that Mother's Day is coming up, and I would like to buy my mom a new vase to keep her fresh flowers in her house. She often forgets to water her flowers and needs a vase that holds a lot of water, all right? And then it gives you the dimensions of the vases, and they're also right here. All right, now I broke them down. So the first number that they give you, that's the diameter. So since it's 10, our radius here is going to be 5, all right? The second number they give you is going to be the height. So in this case, for the cylinder, it's 40 centimeters, all right? So all I did is I just wrote those out. Then I just copied down the formulas that I know from the last few days of the lessons that we've been doing. And then what I did is I just found the volume. So I found the volume of the cylinder, I found the volume of the cone, I found the volume of the sphere, and then I decided which one was the largest. And in this case, the largest number is this one for cylinder. So at the bottom, I just wrote that the cylinder will hold the most water. Okay, so the first problem, pretty easy, pretty self-explanatory. It's just doing exactly what we've done the last 3 days. All right, the next one at the top, number 2, it says, how much more water does the largest vase hold than the smallest vase? Show your work and explain using a few sentences. All right, so I didn't explain using a few sentences, but I wrote out my thinking. So the largest vase was a cylinder, and this is how much it held. And the smallest vase was a cone, and this is how much it held. And so to figure out the difference or how much more, I just had to subtract. And when I subtracted, this is what I got. All right, problem 3, it says, suppose that the diameter of each vase decreases by 2 centimeters. So decrease would mean it gets smaller, right? And the diameter is the whole distance apart. So which vase would hold the most water? Well, in the example of the cylinder, originally the diameter was 10 centimeters. So if it decreased by 2, the new diameter is now going to be 8 centimeters. And then when I divide that in 2, my new radius is going to be 4 centimeters. Then I just went ahead and I used the formula like we did on the front page, and I got the new volume. All right, for all 3, I did the same thing. I took the original diameter, subtracted 2, got my new diameter, and then divided that by 2 to get my new radius. In this case, I figured out that the cone is now going to hold the most water. All right, once again, these notes, I will be posting them, so don't worry if I'm going fast. All right, on the last part, it says that the vase company designs a new vase that's shaped like a cylinder on the bottom and a cone on the top. The catalog states that the width is 12 centimeters and the total height is 42 centimeters. The height of the cone portion is 12 centimeters. The height of the cylinder portion is 30 centimeters. What is the volume of the entire vase? Okay, so in the cone part, we already know the height is 12. And they told us that the width is 12. Well, if I divide that by 2, I'm going to get my radius, and I get 6. And I just went ahead and I did the volume of that. Cylinder, same deal. They told me the height was 30. The width is 12, so I divided that by 2, and I got a radius of 6. And then I just went ahead and did the work. And they want to know the total volume. So in the end, I just added up the 2 numbers, and I got my total volume. All right. Thank you, 230. Talk to you guys later.